Welcome to CloudSec Network. In today's video, we are going to cover how to set up a secure network on the AWS cloud. We will go through how to configure VPCs, subnets, and also gateways in the AWS environment. As of today, there are a couple of organizations that still have all their resources within one VPC and one big subnet. And we're going to explain why that's wrong in the later part of this video. My name is Emmanuel Okon, and I am a certified AWS Solutions Architect professional. I've had the opportunity to work with businesses of all sizes across multiple industries. Over the years, I've witnessed firsthand how a well-designed network with proper segmentation can make or break your security posture. Let us break down some of the core components around networking in AWS. First, we have virtual private clouds, simply called VPCs. A VPC allows you to isolate and segregate your resources within the AWS environment. Think of it as your own private data center in the cloud. Now, within the VPC, you have subnets. These are logical divisions within your network. The key reason to use subnets is to separate resources based on their function and exposure. Finally, we have gateways, which are the key to external communication with the internet. We are only going to focus on two, which are Internet Gateway and NAT Gateway. Let us discuss some of the key differences between an Internet Gateway and a NAT Gateway. An Internet Gateway allows both incoming and outgoing traffic between your VPC and the Internet, while NAT Gateways only allows outgoing traffic from resources in your private subnet. Internet gateways are usually associated with public subnets, while NAT gateways are usually associated with private subnets. Internet gateways are used for public-facing resources, such as web servers that needs to be accessible from the internet, while NAT gateways are used for private resources, such as databases. Imagine you are deploying a web application on AWS. You'd set up a VPC with both public and private subnets. The web servers would sit in the public subnet so they can handle requests from users on the internet. Meanwhile, your database would sit on the private subnet, completely isolated from external traffic. The web servers communicate with the database internally and use a NAT gateway to allow the database to download software updates without exposing it to outside threats. Let's get started with the demo. So today we're going to be creating a VPC in our AWS cloud. If you go and search for VPC, you would see isolated cloud resources. That's what we're looking for. We'll select that. Now, in every single AWS region, there's always an existing VPC, like a default VPC. It comes with some default subnets and also comes with a default security group, a default internet gateway, and a default route table. So let's actually see the VPC that was created in the EU Central region, which is where we are. So if you check that, you'd see some existing configurations. You would see that there are 3 subnets across 3 availability zones. You would also see there's a route table that is pointing to an internet gateway. However, we would want to create our own VPC with our own customizations. And doing that, we'll be able to decide on the number of subnets and decide on many more configurations. So let's get started. Once I click on create VPC, I'll be brought to this interface. You can see you can decide to only create a VPC. However, we would want to create a VPC alongside other configurations like our subnets and our gateways. So once you click on that, you would select VPC and more. Under the project name, I can name this CSN demo. You can name it anything you would want. The CIDR block would simply just be the range of IP addresses that you would want to use. So I would want to use a /24. So I can say I want to use a 10.10.10.0/24, a very small space, 256 IP addresses. You should be very careful when choosing your CIDR block or your IP range. Why? Because you would want to ensure that every CIDR block you choose is unique to avoid conflicts. So in case where you need to do pairing between one VPC and another VPC, the address space for VPC A and VPC B should be different. You will go ahead and see the IPv6 CIDR block. We'll leave that as default, the tenancy as default. What we're interested in will be the availability zone. So for availability zones, we would want to create a minimum, we would want our subnets to be in a minimum of 2 availability zones. It's very important. Initially, I mentioned some organizations that would have one big VPC, one big subnet. It's very bad practice. We would want to make sure we have selected at least 2 availability zones. You can go ahead and select 3 if that works for you. Some services like the application load balancer would even require that it's provisioned on multiple availability zones, a minimum of 2, to ensure redundancy. Once we've selected that, you see the number of public subnets. Number of public subnets right now, we'll leave it at 2, which is fine for us. So 2 public subnets, 2 private subnets, that works for us. And we'll go ahead and see NAT gateway. Be very careful with NAT gateways because unlike VPCs where you'd create and you may not be charged, a NAT gateway would incur a charge. A NAT gateway would incur a charge. So I wouldn't be creating NAT gateways in every single availability zone, which is 1 per AZ. No, I'll be creating a single NAT gateway in just one availability zone, which would make a lot of sense. Then now I'll go ahead and also see VPC endpoint. So VPC endpoint is actually an interesting feature because it allows you to be able to route traffic not through the internet but within the AWS infrastructure. So supposing you want to access S3 for example, so there's a gateway for S3 that allows you to access your S3 bucket without having to take your traffic through the internet. So if you're not taking your traffic through the internet, there's a limited there are limited attacks that you can be exposed to. So you would want to select S3 gateway. However, you can decide to disable it based on your configuration. Then finally, we would see DNS options. It's very important you enable the DNS host names and enable DNS resolution because if you don't enable it, there are some services that might not work. There are services like EFS that will need to do DNS resolution, even ALB, and a couple of other services that will need to resolve a particular AWS DNS. And if you don't have this enabled, those services might not function properly. However, in a situation where you might want to use your own DHCP server or your own DNS server, then it's fine to disable this and then add your DHCP settings in the DHCP option set. I will enable mine and proceed to create. Before I go ahead and create the VPC, I would go up a bit and I will see some services or the services that will be created. So we can see the VPC, we can see 4 subnets will be created, we can see 3 route tables, we can see 3 network connections. So that's enough, and I see these configurations are fine, and I'll proceed to create. Once I click create, I would start seeing the resources getting created. I would see DNS host names resolutions have been enabled, the VPC has been created, subnets have been created. Usually, all this should take a very short time. However, what will take a while will be the NAT gateway because the NAT gateway would also be creating an elastic IP for you to access the internet. So it's going to take a while to provision that within your VPC. So let's wait, and once that's provisioned, we'll continue. Now we are back, and as you can see, our CSN demo VPC have been created. I will click on it and see the options. DNS host names resolution enabled, and let me go to the resource map. You can see the subnets have been created as well with all the route tables. They have all been created, so we can as well also see the internet gateway. If you click on the NAT gateway, to see more details, you would see that the NAT gateway would come with connectivity type as public and a primary public IPv4 address. And also it would have a private IPv4 address that will be in the range of the VPC CIDR block. So this is how you go ahead to create a VPC with subnets, both public and private, alongside internet gateways and also VPC endpoints.